Now in this video, we will be discussing about higher order differential equations. Now I'll show you how these equations look like. So supposing if you have a d square y upon dx square, do you see this is a higher order of derivative? It is a second order derivative, right? Plus y is equal to, I'm just giving you example, say equal to sine x. Now this is an example of higher order differential equation. So this is how your equations will look like. Now before we talk anything about this, there is one notation that I want to tell you about these equations, that when we deal with the higher order differential equation, d by dx, we're going to represent that as capital D. Okay, so this is a derivative. Capital D is simply a first derivative. Okay, it's a derivative operator, we can say. Similarly, if it is d square upon dx square, then we'll write it as capital D the whole square. Okay, so now if I have to use this notation and write down this equation, it will look like d square y plus y is equal to sine x. Okay, now we can simplify this like this: d square plus 1. Look, I took this y out, I took the y common, and then it is equal to sine x. So this is how your typically the equation will look like. Now from here I can just write down the standard form. Now standard form of higher order differential equation will have a function of d, capital D to be precise. You see function of d times y multiplied by y over here, and on the right hand side you will have some function of x. It can be sine x, it can be e raised to x, it can be absolutely anything. Okay, any function of x. So we'll write this as capital X. So the capital X is the function of x. Now this is exactly how the equation will look like. And the next step is, now how do we solve it? Okay, the solution of this higher order differential equation is written like this: the y, or the solution, is ycf plus ypi. It is made up of two parts. Okay, the full form of cf is complementary function, and full form of pi is particular integral. So if you find ycf and ypi, and if you add the two, that is the solution of this equation. So to solve this, we have to find out these two components. And in the coming videos, we will be discussing about how do you find cf and how do you find pi, so that you can add them and write down the final answer for the higher order differential equations. I hope you followed so far the standard form and how it is done. Now the next video we'll be discussing about how we find cf, the complementary function, and particular integral. That's coming up.